So I'm going to walk you through how to find the force between these two objects. This is exactly what you're going to be doing on all of these practice problems. I'm actually going to do the first one here with you, just to make it a little bit easier. So we have two objects, each with a 1 Coulomb charge, and they're both positive. So right off the bat, I'm thinking, okay, since both charges are positive, they will move farther apart. That's because like charges repel. I'm going to write that down. So if they were positive and negative, they would attract. But since they're both positive, they're going to push apart from one another. So our force is going to be positive, and it's going to be pushing out. So I already know that before I even do this calculation. I now need to find all my numbers. So Q1, that's the charge on object 1. I'm going to pick this one on the left is Q1. I could have picked the one on the right, but I'm going to pick the one on the left instead. Let's think. It's going to be 1 Coulomb. That's Q1. Q1 is 1 Coulomb. And Q2 is also 1 Coulomb. So they're the same. So that's easy enough. So these are both 1 Coulomb charges. Now note they're not microcoulombs. They're coulombs. Check out the units. And remember that Coulomb is a really large unit of charge. So Coulomb is a lot of charge. So just be aware of that as you're going through. All right. And then we have our distance between the two, sometimes called R. In this case, we're going to call it D because that's what we have in the formula here. That's going to be 1 meter. Excellent. So we have all our numbers. We have our two charges and our force, our two charges and our distance. Then we need to calculate force. Now to calculate force, we could plug everything into this formula, right? And we could do that algebraically. Or we can go to our class, go get our calculator. This is our Coulomb's law calculator. Fancy schmancy. And then we can plug in our numbers. Now, make sure here your charges are set to coulombs. If they're set to something like microcoulombs or millicoulombs, it's not going to work because that's a much smaller value than coulombs. Make sure you're set to coulombs. And then make sure you set your distance is set to meters and your force is set to newtons. We want to calculate this in newtons. So let's go over here. So we have our first charge is 1 Coulomb. So I'm going to plug that in. Our second charge, also 1 Coulomb. I'm going to plug that in. And then our distance is just 1 meter. Plug that in. And so we should end up with this really large number here. This is 8.987 times 10 to the 9th. So I'm going to write that in scientific notation. You could either write it like this with a caret times 10 to the 9th newtons, or you could write that with a little up here, little exponent. But that's in newtons. It's important that's in newtons. You'll now note that that's actually the same as our K constant. The rounding is a little bit different, but that's going to be the same as our K constant. So you can see that if everything else in here is 1, Fe is going to be the same as our K constant numerically. All right. So that's all we're looking for here. If you can solve like that for all these problems, you're going to be all set. You're going to do really well on this assignment. So as always, reach out with any questions. I'd love to help, and I hope it's a great day.